Hello, this is Geometry 7.2, Properties of Parallelograms. So the first thing that you need to know is what a parallelogram is. A parallelogram is a quadrilateral, so it would have four sides with exactly two pairs of parallel sides. So if this is parallelogram ABCD, then one of the things that means is side AB is parallel to side DC, and I could show that using the arrows here. And then also side AD is parallel to side BC. That's two pairs of parallel sides. That's a definition of a parallelogram. And then I can name the parallelogram. I'm naming a parallelogram. I could use a little symbol here. This little symbol means parallelogram, but ABCD. That's not the only way that I can name the parallelogram. I can name it ADCB. I can name it something like CDAB. But here's something that I can't name it, something like parallelogram BDCA. And the reason why you can't name it that is that doesn't trace out the parallelogram from B to D to C to A, and you'd have the diagonals in there. Now taking a look at some specific properties of parallelograms. Well, one property of a parallelogram is it has two pairs of opposite sides that are parallel. That's a definition of a parallelogram. But another property of a parallelogram is the parallelogram opposite sides theorem. So here's my parallelogram. Call it whatever you want, PQRS. If it's a parallelogram, not only are opposite sides parallel, but opposite sides are congruent as well. So PS is congruent to QR, and SR is congruent to PS. That's the parallelogram opposite sides theorem. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So far we have two properties of parallelograms. Opposite sides are parallel, and opposite sides are congruent. And then theorem 7.4, the parallelogram opposite angles theorem. A lot of times, let's just say you forget some of the properties of parallelograms. You can just look at a parallelogram or draw somewhat of a sketch of a parallelogram and then figure out the properties pretty easily. Like you shouldn't forget that a parallelogram opposite sides are parallel. That's a definition of a parallelogram. And then if you drew a fairly accurate diagram of a parallelogram, you could probably figure out that the opposite sides are congruent. And kind of the same with the parallelogram opposite angles theorem. You can probably figure out that the opposite angles, such as angles O and M in my parallelogram LM and O, they would be congruent. And then also the opposite angles L and N are congruent. There's the parallelogram opposite angles theorem written out. The opposite angles have to be congruent. That's the third property of parallelograms that we have. And then another property of parallelograms that we have deal with the consecutive angles. So the parallelogram consecutive angles theorem states the consecutive angles, which just mean one right after another. Even more specifically, it's the consecutive interior angles, such as angles S and V, or it could be angles S and T, but the consecutive angles are supplementary. And then the reason why is you can think about your parallel lines and a transversal. The consecutive angles are actually consecutive interior angles or same side interior angles. That's why they are supplementary. So in my diagram here, angles S and V, or the measure of angle S plus the measure of angle V, those are consecutive angles or consecutive interior angles. The sum would be 180. I could also say something like the measure of angle S plus the measure of angle T is equal to 180. The measure of angle T plus the measure of angle U is equal to 180. And the measure of angle U plus the measure of angle V is equal to 180. All pairs of consecutive angles, the sum is equal to 180. And the last theorem, or the last property of parallelograms, is the parallelogram diagonals theorem. So recall a diagonal is from one vertex to a non-consecutive vertex. So EG would be a diagonal in this parallelogram. HF would be a diagonal in this parallelogram as well. But parallelogram diagonals theorem states the diagonals of a parallelogram bisect each other. So if point I is the intersection of the diagonals, what that means is in this diagram, EI is congruent to IG, and HI is congruent to IF. Those diagonals bisect each other. So there is the theorem written out. Be careful. The diagonals bisect each other, but the diagonals aren't necessarily congruent. So don't think that in my diagram, EI is congruent to HI. It's not. EI is only congruent to IG. HI is congruent to IF. And you could tell by my tick marks here, they're not all congruent with each other.